Well, hello, and welcome to our Unit 7 test review. Let's get you ready. Make sure you have something tasty to drink, a nice big glass of water, have a nice snack, and maybe have a puppy nearby in case we run into an anxious situation. Or maybe you can snuggle with a turtle. I don't know. Let's see what happens. But here we go. Make sure you've done these problems before I have so that you can check your work. That's the best way to do this whole thing. But I'm going to go ahead and get started. So determine whether each inequality statement is true or false. So let's see what we got here. So -6, so this symbol right here is a less than symbol. -6 is less than 8. You know what? This is a negative number. This is a positive number. It's so less. So this one is true. This is also the less than symbol. 2 is less than -7. That is so false. 2 is bigger than -7. If you put it on the number line, 2 is to the right. -14 is less than -16. Let's take a look at that on the number line. So maybe that's 0. Okay, this is going to be -14, and this is going to be -16. As you travel along the number line, these negative numbers actually get like bigger, but in value, they're getting smaller. So let's see if it's true. -14 is less than 16. That is also false because -14 is closer to 0, which means it's bigger. It's bigger. Number 4, -15.5. Again, I want to see that on the number line. Let's see. So I got 0 here. -15 is going to happen first, and then -15.5. Go ahead. Don't be afraid to write the number line to kind of see what's going on. So this guy is bigger, so let's see if that's what the statement is saying. -15.5 is less than -15. That is a true statement. Here's a true statement. -9.4 is greater than -9.7. That is true. So let's see which ones fit this situation. And again, I'm going to use a number line to get me going. I like to put 0 because it helps me kind of see where things are. And I have -9.4. And then somewhere over here I have -9.7. So let's see what fits. -9.4 is further to the right on the number line than 9.7. To the right, that is true. -9.4 is further to the left on the number line. Nope, it's to the right. That is not true. -9.4 is less than -9.7. It's not less, it's bigger. It is closer to 0 on the in the negative numbers. -9.4 is greater than -9.7. It is greater, totally greater. -9.7 is less than it is. It's super less. -9.7 is greater than -9.4. You know what? If both those numbers were positive, that would be true, but they're negative, so not true. Oh, you're doing great. Keep it up. What is the correct order on the number line? So, quick number line. Got my 0 here. These numbers are positive. These numbers are negative. So, when I look at these, this is my only positive number. So, if I'm going from left to right, that means this number right here is the furthest to the right, which means this one's out. Can't be that one. And these all end with that number. So far, A, B, and C are in the process here. I'm going to change these so I can see them a little better, their value. So let's see. This one is 1, and that's 6/10. And that's 1 and 9/10. And then 17/10 is actually 10 goes to the 17 once with 7 left over, and it's a negative. So if I have to order these, I would put these like which one's the most negative, which one's the furthest to the left. It is going to be this guy right here, -1. So which one has that? That's this guy. So it must be B. B has to be the answer. That's the only one that works because they're trying to sneak the other ones. So it's got to be B. Let's see. Lowest. Okay, let's see. Put these least to greatest. Got to pay attention to that because sometimes we might ask you for greatest to least, kind of sneakily. So what I do when I see that is just underline it so I don't lose track of that. So the least, which is the biggest negative number, is going to be New York. So New York is the first one. And then the next one is, I'm going to mark it off so I've already done it. Next one is Oklahoma. And their state motto is Oklahoma is okay. I don't know why they didn't say we're exceptional or super amazing, but they didn't. Oklahoma's just, it's okay. Then we got Louisiana, then Florida's the next one, and then Hawaii is the last one. Lowest temperatures. Wow. Lowest temperature in Hawaii is -12. I think I'm going to visit there rather than New York or Oklahoma. Order these numbers from least to greatest. So my smallest number is the most negative, which is -2. Cross that out because I already used it. My next negative, most negative, is -1/4. And I'm checking them because I don't want to miss any. Students sometimes miss one, so that's what I'm doing. Okay, now I'm on the positive side. I got my 0, and then 1/4 is the next one because I got to climb back up on the number line. Okay, I'm going to check these 1, 2, 3, 4, 5, 6. Make sure I got 1, 2, 3, 4, 5, 6. 6 things. There you go. Number 6, order these from least to greatest. Now this is absolute value, which is distance from 0. So right above it, I'm going to change it to what its real value is. So -2 is 2 away from 0, so I'm going to think of it as that one. And -1.4 is 1.4. So I'm going to plot those numbers instead. So here we go. Oh, nothing's negative here. Everything's positive. So I've got 0, that guy. The next smallest number is 0.7. Next smallest one is 1.4. Then 1.9. And then 2. Now, even though it says -2, that's not what it's saying. The absolute value of -2 is how far away is it. So the value of that one is actually 2. All right, we're on number 7. We're doing great. If you need to pause, take a break, run around the house, go ahead and do that. Just, don't scare anybody. Okay, so we need to match the best possible mathematical statements. All right, the wording of these is a little bit funky, so sometimes we have to read them twice. The number -20 is less than, so I'm looking for a less than symbol, the number 5. The number 20 is less than 5. Oh, right here. -20 is less than 5. So this is going to go with story A. If you didn't get a chance to do these, make sure you pause the video and go do these yourself. And now you're using this to kind of like check your work, see how you're doing. The number 5 is greater than the number -5. So where's that one? The number 5 is greater than -5. It's this one, B. Okay, the number 5 is a distance from 5 units away from 0 on the number line. I might wait on that one. I'm going to pause on that one because the wording of that one's kind of funky. And so let's see if I can maybe narrow it down by doing some of these ones. The numbers 5 and -5 are the same distance away from 0 on the number line. Boy, that's kind of... Oh, same distance. Same distance. We're talking absolute value. So I'm going to look for the one that has absolute value and they're equal. That's going to be this guy right here. Yep. Absolute value. Okay, so this one's done. The number -20 is further away from 0 than 5 on the number line. Okay, so further away, so we're talking absolute value here. So where's my absolute value? Okay, I've got a -20, and okay, I've got 2 spots here. Now we're looking at absolute value, so it's both of these right here. It's further away, which makes it greater. So what letter is that? That's going to be an E right here. The -20 is more than 5 units away from 0 on the number line. Another absolute value one. So that's going to be this guy right here, which makes it greater than 5. So that last one, it goes with this one, C. So let's read it and let's wrap our head around, okay? And what I'm showing you is a strategy that you can use. Like if there's one that's just the wording's too funky, just go ahead and like skip it and then come back to it though. The number -5, okay, which is this one, is a distance, so that's why we see the absolute value, of 5 units away from 0 on the number line. Oh, it's basically telling us the absolute value of -5 is 5. Yeah, I see that now. Let's continue. Oh, awesome. Let's find values here. Which one's greater? 20 is greater than -20. Absolute value of 12 is 12. Get in the habit of writing the number above it or below it, the true value of it. The absolute value of -12 is 12. These are equal. 17, okay, absolute value of -19 is 19. 17 is less than 19. 7 is greater than -7. because 7 is positive. Okay, absolute value of negative 29 is 29. Absolute value of negative 35 is 35. So 29 is less than 35. We've got 42, because these are absolute values. We have 45. Notice they're both positive, because it's all about distance from 0, which is going to be positive. 42 is less than 45. It always is, always will be. 14, I've got a negative 23, but it's absolute value, so I'm going to do positive 23. And 14 is less than 23. Oop, okay, this guy right here. Let me check on the number line real quick. So if I have 0, 14 is going to happen, negative 14 is going to happen, and then negative 23. So the one bigger and the negative is the one closest to 0, which is negative 14. So negative 14 is greater than negative 23. Consider using the number line if you need to. It helps. It helps. Select all the numbers that are solutions to the inequality of g is less than 11. So is 6, and I'm just going to plug the number in to g, okay? Is 6 less than 11? Yes. Is 10 less than 11? Yes. Is 11 less than 11? No. It's exactly 11. I would circle it if it said this. That would be saying, is g less than or equal to 11? But it doesn't say that. It says it has to be less. Is 0 less than 11? Yes. Is 10.99 less than 11? Yes. Is 11.01 less than 11? No. It looks like I have 4 choices on this one. Draw a number line to represent this. I'm going to put dot at 11, okay? And I have to figure out which dot to use because it's just less than. I'm going to have an open dot. If it was less than or equal to, I would have a closed dot because it can include it. Now I have to do an arrow, and it says less than 11, so my arrow is going to go this way. And then this is how I can check it. I'm going to pick something this hits. I'm going to pick 8. Is 8 less than 11? This is true, so my arrow is facing the correct direction. Number 10. Let's see, Claire. She's been running 1 mile times a week for the month. She recorded her fastest time as, okay, that's her fastest time. So I'm going to write my little inequality over here. So her time, looks like we're using t as time. So fastest time. So that's the fastest she went. So her time is going to be, all the rest of her times are going to be greater than or equal to 6.25. And her slowest time was 9 minutes. So her time is going to be anything less than or equal to 9 minutes. So now I'm going to look over here and see which ones match that. Oh, I made this one. That one's true. Let's see. T is, okay, this is saying T is greater than 9. I just said it's less than 9, so it can't be that one. 6.25 is greater than T. 6.25 is greater than the time. 6.25 is greater than the time. No, that's not true. The time needs, no, it needs to be less than that. Totally true. 9 is greater than the time. Yep, that works. Yep. And I like to read it the other way. Like if you flip it, sometimes when it's written this way, it's kind of hard to see it. So for me to see it a little bit easier, I flip them. So I start with the T, and then I have to flip the symbol the other direction, and then 9. So this is saying the time is less than 9. That's what makes it more true. In fact, I'm going to do it on this one because sometimes it's hard to see. I'm going to rewrite the inequality, but and the symbol is facing this way, so I'm going to face it the other way. Keep it true. I'm going to see if that's true. Is my time greater than or equal to 6.5? That is true. Let's try it back on this one because this was kind of hard to see. I'm going to flip it. I mean, it's hard to tell. So I'm going to start with the T. I'm going to take this symbol, I'm going to flip it so it points the right direction. Is my time less than or equal to 6.25? No, it's not. It's bigger than that. It's so not. Select all the true statements. Again, inequality, so go ahead and write like the true value above it. It's going to be positive. So I'm just going to run through and do them all. So these are 15, that's a 12, that's a 12, and that's a 10. Yeah. And even if this was absolute value of 10, I'm still going to write a 10 above it because it's the positive value of it. Okay, now we can do it. Does 10 equal 10? Yes. Is negative 15 less than 20? Negative 15, it is. It so is 4 less than 10? It is. Is 15 less than 12? No, it's not. Is 12 less than 10? It is not. It looks like 3 things work there. What are some of the values of S? So I'm going to plug in 25 in where S shows up. So is 25 less than 24? No. Let's try 21. Is 21 less than 24? Yes. Is 21 greater than 0? Yes. So it's true for both situations. Let's try 24. Is 24 less than 24? It is not. Let's try 2. Is 2 less than 24? Yes. Is 2 greater than 0? Yes. Let's try 0. Is 0 less than 24? Yes. Is 0 greater than 0? No. Only 2 of them work on that one. Ooh, the plot thickens. I'm almost ready for a snack. Let's see what happens. So Han has more than 12 cows. Of course he does. So Han has greater than 12 cows. Jada has more cows than Han, so Jada has more than Han. I'm just writing down what I see. Jada has more than Han, okay. Priya has fewer than Han, okay. All right. So let's use these things. So are some of these down here? Let's see if we can find any of these. H is greater than 12. That one's down here. P is greater than H. I'm going to look for this one. Okay, right here. This one might be this one, but I'm going to rewrite it just to see. Okay, so I'm going to come down here to this one. I'm going to flip the symbol. So P. Does that match? It doesn't. Not true. Okay, let's check some of these other ones. Is Han have less cows than Jada? Well, yeah, because Jada has more than Han, so that is true. Does Jada have more than 12 cows? Well, Jada has more than Han, right? And Han has more than 12, so Jada's definitely going to have more than 12. That is true. Priya has greater than 12. Well, Priya has less than Han, and Han has 12, so no. Priya has less than Jada. Let's check that one. Priya has less than Jada. Oh, yeah, because Jada has more than Han. Priya has, oh, yeah, totally, less than. Man, that was crazy talk when you do it that way. But we could ask you that. Be ready for that. You got this. All right, we're going to plot some points. Okay, negative 3, so I'm going this way, and then positive 4. Okay, I'm going to get rid of those because I just want the dots. Negative 3, positive 4. Okay, that's in quadrant 2. 3, 4, so I'm going to go positive 3. I'm going to go right and up 4. That's in quadrant 1. I'm going to go 3, negative 2. That's in quadrant 1, 2, 3, 4. That's in quadrant 4. And then negative 3, negative 2. Right there. We've got ourselves a square. Yes. All right, keep in mind when we're plotting stuff, we plot the x first and then the y. Another way to look at it is we go left or right first, kind of like you're on a number line. And then we go up or down second, like you're on a thermometer. So left and right, if it's positive, you go right. If it's negative, you go left. Thermometer, if it's positive, you go up. If it's negative, you go down. Ooh, some more plotting. Yay. Oh, we just got to give coordinates. We can do that. So B is at, it didn't go left or right, so we say 0, but it went up 5. E, we went to the right 1 and up 2. These are kind of like given directions. We went to the left 3, so that's negative 3, and then we didn't go up or down. For C, we went to the left 4, and we went up 3. And then for D, we went to the left 5, which is negative 5, and then we went down 3. All right. And bonus conversation, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We recognize them in absolute value, not Roman numerals. Woohoo. Select points that would form a square with the origin at its center. Okay, so I'm going to plot a couple of these. So we have 8, negative 8. We have 8, positive 8. We have negative 8, positive 8, and negative 8, negative 8. Yes, if I connect those, totally a square. This next one, negative 4, 3, negative 4, negative 3, 4, negative 3. Okay, I can already tell, like, this is going to make a rectangle. Interesting. If you look at the things, 8, 8, 8, 8, 8, 8, 8, 8, this one's going to make a square. All the same. That one's going to make a square. Not. So that one is going to make like a rectangle. So if they're going to make a square around the origin, and if you're not sure, go ahead and plot them. Plot them to make sure. But that's one way to look at it. And the key around this one is the origin at its center. If it doesn't say the origin at the center, the best thing you can do is just plot it and find out. Ooh, quadrant question. Quadrant question. Okay, so this one, it looks like we've got time is right here. All right. And then this looks like elevation right here. So we've got time and elevation. So Andra at 1 p.m., which is right here, she was above sea level. So that's going to be quadrant 1. Okay. At 5 p.m., so 1, 2, 3, 4, 5, 56 feet below sea level. So that's down here. So that's going to be quadrant 4. At 8 a.m., so that's 12, 11, 10, 9, 8. Above sea level. That's right there. So that's quadrant 2. The other one we didn't use is quadrant 3, which is right here. Here are 4 points on a quadrant. Label each point with its coordinates. Oh, we're going to label again. Just give me directions. Over 4 and up 3. This is in quadrant 1. Over 2, which is negative 2. Up 2. This is quadrant 2. N, you went to the left 5, which is negative 5, and you went down 2, which is negative 2, and this is in quadrant 3. P, you went to the right 3, which is positive 3, and you went down 3, which is negative 3, and this is in quadrant 4. Yes, what's next? Which list shows the factors of 60? Now, factors are the smaller numbers, the numbers that make it up, okay? I know there's more than this one, so that one's out. Okay, it can't be that one. There's quite a few that work. Okay, little factor rainbow. So 1 times 60 is 60. 2 times 30, 60. 5 times 12. So those all work. But there's more. 1, 2, 5, 6, 10, 12. Oh, this one's missing 60. Or this has been 30 right there. So this is out. Let's see if these all work. 2 times 30. Okay, 3. Oh, yeah, 3 times 20 works. This is good. So this one was close. It just was missing some of them. What is the greatest common factor of 8 and 60? All right, we already have 60. 60 is right here. Got a nice list of those. So that's good. Let's do the factors of 8. So the factors of 8 are going to be 1 and 8, 2 and 4. Is there more? Nope, that's it. So what's my greatest, greatest common factor? So let me show you something. So greatest common factor, I want the biggest small number. Factors are the small numbers, the pieces that make it up, but I want the biggest one, the biggest small number. So 1 is in both of them, 2 is in both of them, 4 is in both of them, 8 is not in both of them. I want 4. 4 is the biggest small number. What is the greatest common factor of 60 and 100? Okay, 100. We already have 60 again, but let's do the factors of 100. Okay, 100 is going to be 1 and 100, 2 and 50. 3 does not work. It's going to be 4 and 25. Oh, 5 works. 5 and 20. And then 6, 7 doesn't work. 8. Oh, 10 times 10. That works. All right, let's find the commons. 1's common. 2's common. 4's common. 5's common. 10's common. 20's common. Not 25. Not 50. Not 100. 20. The greatest common factor. The biggest one is 20. Go us. Yes. All right, we've got a team going on here. Looks like we have 20 juniors and 32 sophomores, and we're making groups. Okay, as soon as we hear groups, making groups, we're dividing these up a little bit, so we're talking factors. Okay, so let's get the factors here. So the factors of 20. Yeah, let's go ahead and play the factors out here. We can make this a group, but I can do factors. So factors are going to be 1 and 20, 2 and 10, 3 does not work, 4 works, 4 and 5. I think we have them all. Okay, and we got the 32 sophomores. Okay, let's work the sophomores out. So we got 1 and 32. We got 2. Yeah, 2 works. 16. 3 does not work. 4 works. 4 and 8. I think that's it. That's all of them. Different combinations. Okay, so the different ones that work where we have common things going on here. Let's see. We got one's common. We can make one group. We can totally make one group that has like a 20 and a 32 in it. We got those are common. Those are common. 5, 8, 16. That's it. All right. She wanted to form as many groups as possible, but these looks like the most she can make is 4 groups because the greatest common factor, the biggest small number is 4. So she can make 4 groups. That's the biggest one she can make. All right, let's keep going. Number 22. Okay, we got cars traveling all over the place. We have car A that is going every 6. Let's see, every 6 minutes it crosses the line. So let's get a couple of those. So 6, and then it's going to cross it again at 12, and then it's going to cross again at 18, and then 24, and then 30. And if I need to do more, I'll do more. Let's talk about car B. Car B looks like it goes 8 minutes every lap, so 8. And then it's going to hit it again at 16, and it's going to hit it at 24. Now here's the deal. What we're doing, notice we're doing multiples. So just like the other one I did, least common factor, I'm doing least common multiple. But for this one, I want to find the least. I want to find the smallest multiple, the smallest big number. Okay, and we actually found a common one. 8s don't match, so then we have 24 matches right here. So we know they meet up at 24 minutes. And then you can use that 24 to like figure out the next one because we know they're going to meet at 48 minutes because it like doubles it. And they're going to meet at 72 minutes because it triples it. So as soon as you find the first one, you can actually find the other ones. If we continued on our lines here and putting the multiples down, we would see they meet up at 48 and 72, which is super great. Ooh, car C and D, when did they come around? All right, let's talk about these guys. All right, car C, what are you doing? C looks like they go 10 minutes. So 10, up 20, 30, 40. Do I have a time limit? Nope. 50, 60. I'll go up to that one. And then car D goes every 12 minutes. Now, I know I'm doing multiples because it's growing. That's what it wants. 12, 24, 36. Do I have any matches yet? I don't. 48, 60. Oop. Ding, 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 ding. Found a match. 60. So the first time car D and C will match when they hit the finish line will be at 60 minutes. And if we know 60, we know 120, which is also on here. And then also 6 at 180, which is not one of the choices. So we're done. Good job. Find all the multiples of 12 and 20. Okay, we're not going to find all of them because it's endless. But let's find a bunch of them because we're ultimately trying to find the least common multiple. So we're trying to find the smallest, a big number. So I'm going to do 12, 24, 36, 48, 60, 72, 84, 96. Those are all the ones of 12, and I get them from here. And here's all my choices. So how about for 20? 20, 40, let me know when you find it. 60, 80, oh, I found it. Actually, I found it a bit ago. The 60 right here. And if we keep going, we're going to find another common one. We will. Probably like 120. Yeah, we definitely would find it at 120. But we want the least one, the smallest one. Oh, hot dog buns. Hot dogs. Love a good hot dog. Do you put ketchup on your hot dog? If you're from Chicago, I hear you're not supposed to do that. If you're really a true Chicago person, you're not supposed to put ketchup on your hot dogs. I think you can, just don't tell anybody. All right, so we got hot dog buns, and yeah, you're right. It's totally true. I don't know when the last time you guys went to the store and bought a hot dog buns, but buns and hot dogs come in different sizes, so we're going to try to match these up, and so these are multiples. So the more you buy, the more you have. So let's deal with the hot dog buns. Okay, so let's do the hot dogs. Okay, so hot dogs. Hot dogs come in packages of 10. So I'm going to have 10, 20, 30, 40, 50, 60, 70 hot dogs. Can you imagine 70 hot dogs? That'd be awesome. All right, let's talk about the buns. Okay, so packages of 8. Okay, so these are the buns. So we have 8, 16. We're looking for where they match. 24. Any matches yet? Nope. 32. Match. Nope. 40. Oh, ding, 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 ding. We found it. The least common multiple. The smallest big number. 40. So it's not 40 packages. Keep in mind, because we got to listen to the question. Because if the question's asking how many packages of each, for hot dogs I need to buy 1, 2, 3, 4. I need 4 of those. And for buns I need 1, 2, 3, 4, 5. 4 of those and 4 hot dog things, and then 5 buns, packages of buns. Students often do a misconception and they just write 40 down. And we're not going to buy 40 packages. We're going to buy 4. Number 26. We're doing great. You're doing great. Let's see. Okay. Karen we got bananas, we got oranges, we got apples. Oh my goodness, we got so much going on here. All right, I'm going to start listing these down here because these are factors. This is a factor thing because we're trying to make fruit baskets. I'm going to use this tiny little space down here and work it out. So I'm going to do bananas right there. I'm going to do oranges, and I'm going to do apples. I'm going to do factors of 36, factors of 54. This is a lot going on this one, so just, you got this. All right, you'll be okay. Whew. All right. Factors of 36. So 1 and 36. 2 and 18. Yep, 3 works. 3 and 12. 4 and 9. And 6. Yep, 36. Ding, ding, ding. 54. 1 and 54. 2 goes into it 27 times. 3 goes into 54 because 5, 7, 8. 5 plus 4 is 9, and 3 goes into that, so it works. So 3 goes into 54 18 times. 4 does not work. 5 does not. 6 works. 6 times 9 is 54. 7 does not work. 8 does not work. Done. Ding, ding. We're going to do 90. 1 and 90. I know this is taking a while. You're doing great. Keep up here. 2 and 2 times 45. But you already did it. You already solved this one. So now you're just watching me solve it. You can fast forward this. Totally. I would if I were me. So 5 and 30. Oh, 15. No, 18. 5 and 6 and 18. 15. I was getting squished up here. Oh, 9 and 10. There they all are. Let's find matches. Okay, so there's a match. Those 2s are matches. 3s are matches. 6s are matches. 9s are matches. 18s are matches. And that's it. So it looks like if we're gonna make baskets, we can make. Looks like we can make 18 baskets. So how many baskets can we make? Because that's what it's asking. How many baskets can we make? We can make 18 baskets. And let's talk about those. Okay, if we're going to make 18 baskets, how many bananas am I going to need? if I can do 18 baskets. So remember, I have 36 bananas. So if I'm making 18 baskets, I have 36 bananas. I'm going to put 2 in each one. If I'm making 18 baskets and I have 54 oranges, 54 divided by 18 is 3. Apples, I have 90 apples, and if I make 18 baskets, 90 divided by 18 is 5. And I think my answer key says 9 baskets. So if we did 9 baskets, we're going to have more. We're going to pretty much have double everything. So that'd be 4 bananas, 6 oranges, and 10 apples. So that's where the answer key gets it. But if we want to make the most baskets possible, we can make 18, as we found here. This guy right here, we can make 18 baskets. So very common again, what students might say is they might say 18 as the answer, but 18 is the answer to the number of baskets. But then you got to find how much of each one is in each one of them. Are we in the last problem? We're on the last problem. Woohoo! Wait, are you still listening? Are you even here? Are you letting the video just play and let your dog listen to it? Okay, that's hysterical. But, all right, puppy, listen up. Last problem. We can do this. Come on. Puppy, you got this. Come here, puppy. Good puppy. All right, find the product of, okay, product means to multiply. I almost put an X for multiplying. Now, X does mean multiplying, but the closer and closer we get to algebra, X means a variable, an unknown, so we got to switch to, like, the dot. So 9 times 15, or parentheses. So 9 times 15 is 135. That's awesome. Greatest common factor of 9 and 15. So greatest common factor. So I'm finding the greatest, the biggest factor, the biggest of the smallest number. So let's do it. So factors. Factors of 9 are 1 and 9, and 3 times 3. Yep. Factors of 15, there's not a lot of them. 1 and 15, and 3 and 5. The common ones are 1 and 3, and that's it. So the greatest one of these, wait, I want to keep that. The greatest one of these is the 3. That wasn't very hard. Least common multiple, so least common multiple. So I want to find the smallest big number. Okay, so I'm going to do run a bunch of 9s out. And then we'll kind of see, so 9 times 2 is 18, 9 times 3 is 20, whoa, that's a weird number. 9 times 3 is 27, 9 times 4 is 36, 9 times 5 is 45, 9 times 6 is 56, that's enough. If we need more, we'll do more. Now we're gonna do 15. 15 times 1 is 15, no match. 15 times 2 is 30, no match. 15 times 3 is 40. Ding, 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 ding. We've got a match. The least common multiple is 45. Whew. Did we do it? We did. Answer key. I had the answers the whole time? Yeah, I know you did. All right, practice what you need to practice. You got this. I know we did a lot. Thanks for hanging in there with me. You are super duper great. And even if I'm talking to your dog or your cat, your dog and cat is super great too. All right, I'm going to